Hi, first of all, thank you for coming to this talk and to this guix.social event. My name is Giacomo. I've been a member of the Geeks community since 2019. You may know some of my work, such as SOPS Geeks or the Rootless Podman service type, or the REST Backup service type, or maybe Geeks Home.files, or any other of my Geeks contributions. I'm here to speak about one of my latest projects in the Geeks space, which is the Gocix channel, which is a channel about bringing OCI backed services to the Geeks systems. This means that it contains Geeks system services which are backed not by Geeks packages but OCI or Docker images. I would love in the long term to make Gix usable as a self-hosting platform, as the perfect self-hosting platform. And to do so, I would love in the future to work on some kind of YUnO host for the Gix system, which is a web application, maybe in some ways similar to Cockpit, if you know that. To be able to manage applications and configuration on a given server, and I think it would be awesome to expose Geeks specific features to non-technical users through a web UI. I'm thinking, for example, of rollbacks or different user profiles and so on and so forth. Please bear with me, I'm not a professional streamer, I'm not awesome like David Wilson from System Crafters. Go check it out if you don't know it. And yeah, let's start. So if you've been using Gix for some times, you are probably aware that many applications are packaged in OCI / Docker images, but they are not in Gix. And a good subset of them is written in either Node.js, Go, Rust, or languages that, as a general approach, encourage application to have huge dependency graphs. The Gix project accepts package contributions that comply to very strict standards in terms of whether the package and its dependencies can be completely built from source. This is the reason why practically no Node.js applications or in general JavaScript application is packaged in Gix mainline, and due to the bad state of bootstrapability in the JavaScript ecosystem, for example, some of them may even never be there. And this is a shame because the Gix system is completely usable for self-hosting purposes and in general for most, I would say, personal computing purposes. This phenomenon of huge dependency graph is not uncommon in the modern software development environment. It's quite problematic. It shows that nobody has the time to put the effort of auditing or even reviewing, in most cases, the dependency graph, and is the cause of many supply chain attacks in the last years. And I would say that dissecting the interest which prevent this kind of investment in building software products with a sustainable maintenance is out of scope for this video, but it is useful to introduce why I'm presenting the OCI service type, why I wrote it, and why I believe that it makes I would say, for sure not perfect, but a good middle ground between pragmatism and usability and the Gix system ethical stances. The Gix system, as I said, is completely usable even today for self-hosting purposes. If you're used to Docker Compose, you can, or Podman Compose, you can definitely use them on the Gix system and they work as expected, but they have, I would say, a minor disadvantage, which is that the Gix system is very consistent and very elegant in how you are able to define system configuration and to manage services at runtime. And once you start introducing Docker and or Podman in the equation, it becomes, in my opinion, less elegant because then you have to remember two different sets of commands and you have to manage Docker or Podman backend services in a different way from the Gix provisioned ones. So the OCI service type aims at implementing shared services that look and feel native, so you can configure and manage them with the usual consistent interface that Gix exposes, but are implemented under the hood as Docker run or Podman run invocations. So for example, this code that I'm showing provisions two different Shepherd services, one for Prometheus and one for Grafana. Each OCI container configuration record is mapped to a Docker run and or Podman run invocation, and you should be able to interact with these services as if they were native processes on your system.
So let's start with a very simple example. We have here a small guide script of around 70 lines, which allows you to check whether someone is in the office or not. It does so by answering calls on an HTTP URL, and when you call the who's in URL, it will check whether the office is empty or not, and it will return an answer through HTTP, and it will write the state of the office in the configurable directory that you pass it in its first command line argument. So this can be any kind of backend service. It could be a database, it could be your web application, it could be whatever you may consider generically as a backend. The script is actually pretty simple. It does some kind of basic arguments validation as first task. You have to mandatorily give a data dir to the script so it can know where to write its state, the state of the office. It does some basic checks to assign the default values to the port and to the URL path which it will answer for the state of the office. So in this case, if you call it with just the default mandatory argument, it will listen on the 7777 port, and it will match the who's in URL path. So as soon as it starts, it will listen on the port that you gave to it on all IPv4 interfaces. This can be obviously made to work also in IPv6. And as soon as it starts, it listens for HTTP request. As soon as it gets a request, it matches the path, whether or not it matches the input path, which is not mandatory. If the path matches, it will write the office state into the office file, and it will return the office state as an HTTP response. If the path does not match the configured URI, it will write another state in the office file, and it will return the unknown path string appended with the path that you called through the HTTP request. So we can see a very small usage example. So to run the backend script, you can just call it as if it were an executable. As you remember, if we call it without arguments, it will crash because it requires data dir to write its state. So we can just pass it tmp in this case, and it will start correctly. We can test that it is running by calling the configured Husin URL. We expect for this to have the out of office answer and to have the empty state brought to the office file. So let's call it. As we expected, we get the out of office. Let's now check whether it wrote the correct state in the office file, and it is empty. So if we try to call whatever other URL, it will say unknown path, and it will write a different state into the office file. So the behavior is sound. We can now try and run it in background. So for this, we will use a very nice feature of Shepherd introduced recently after or at 1.0. I'm not sure, but it's quite nice. And it is the transient services. So we can call herd spawn transient and then pass it a command line to have the shepherd start a background service, which we can interact with the herd command line just as if it were a regular service. So let's close this other shell and let's spawn the new shepherd service. As you can see, we now have created a new transient service. We can verify this by checking with herd status. As you can see, we now have one transient service. We can check its status, and then we can check whether it is actually doing what we expect. So we can see that the command line is correct and that the status is of the service is running, and it clearly states that it is a transient service. So if you restart the shepherd, this is my home shepherd. So if you just log out and then log back in, you will see that this service is not alive anymore, and you have to start it again or to add it to your Gix home configuration. So let's check whether the script actually does what we expect. Sorry. So curl HTTP. We expect it to answer out of office. It does so. Let's check whether it wrote the correct state in the office file. It did. Let's check whether with any other URL. Exactly, it does answer unknown path. Let's check whether the office state is correct. Exactly, the office is on fire, so it is what we expected. Now let's see a second example. So the second example, you can imagine it as some kind of middleware service, or maybe if you're familiar with Lemmy, you can imagine it as if it were Lemmy UI or some kind of unofficial UI that actually connects to the Lemmy backend, which is represented by the scripts that we saw before. It is very similar to the backend service. This front-end service takes the same way as before a data dir to write or actually to read the office state. In this case, it takes a backend API so that it can ask for an office state through HTTP. And in option, it takes a port just like before. Let's go quickly through its source code. It's quite similar to the first one. It listens on a given port. The default is different, so if we start them both on a single machine with default configuration, they won't clash. And what it does, it checks this time an hard-coded path, the doorbell path. So if we ring the doorbell on this front-end service, it will check the backend state, the office state through the backend, through HTTP, and it will check the office state through the file that we provided. So let's quickly test it the same way as we did for the first one. So the same way as before, if we call it without arguments, it will crash because it needs a directory and an API URL. So let's give it the tmp directory to check the office state, and let's pass it the backend URL. So as we just shown, we have now a transient shepherd service, which is hosting our backend, and we can check it is running just by running curl against this URL, or by checking the status of the transient service. So the backend is running. Let's try starting the front end. The front end is now running. Let's try calling it. So we are using the default port for the front end or the middleware service. So let's use it, and let's ring the doorbell on the front end service. So we can see that it checked the backend API status, and it checked the content of the file. We can prove this by calling an unknown URL on the backend. We can now see that the office is supposed to be on fire since we called an unknown URL, and we can now double check that by calling the front end, the office state will be set to empty. So we get out of office from HTTP, the file is supposed to contain empty, and it does. So we checked that the front end is running. Let's try spawning a transient service for this as well. Exactly. Now let's check that it is correctly running in Shepherd. Now we have two different transient services, and let's see the status of the backend, the status of the front end. Let's try calling the backend on an unknown URL, and this is just to show to you that the scripts are actually working and doing what we expect them to. So let's call an unknown URL on the backend, check the office status, it should be on fire. It is. Let's now call the front end, let's ring the doorbell, and the office is supposed to be empty. Exactly. So now we have two services running on our Shepherd instance, and we can now try running them as isolated OCI containers.
Let's have a look at the configuration that you need to add to your home environment record to actually enable OCI backed Shepherd services. In this case, we are using a guile OCI image. The OCI image is currently defined in the GNU Services Docker module. It will be I'm proposing a change to move it to the GNU services container. Either way, you can find the documentation in the Guix manual for now. Let's just say that we declare an OCI image, which packages the Guile Guix package, and it is called just localhost/Guile, and this is the image that we will use to execute the front-end and the backend script, and then we define two G expressions referencing the source code for both scripts. So in this case, it is just a call to local file, and we pass it a proposed name for the store path and the path on my host machine where the source code lives. And this is what we actually need to add to our home configuration. So let's say that in the simplest case, in case you're using Docker and it is already configured on your machine, you just need to declare your containers. So such as in this case, we define one extension point for the home OCI service type, and we ask it to provision for us an OCI network through which the containers will be able to connect to each other, and the shared volume through which the container will be able to share state and especially the office file. And it's mostly that. Besides this, we only have the two containers. We define a provision name for them. This is the name that we will use on the command line to reference them in herd commands. So for example, we will be able to use herd status backend. We define the image, the OCI image. We define the entry point, the executable that is used as an entry point for the OCI container. We define the network. We pass some arguments to the entry point, and we map volumes and the source code for the script. So this is the equivalent, each one of these, so each one of the OCI container configuration records is equivalent to one OCI runtime call. It may be either podman run or docker run, and arguments mostly map to options of these commands. So let's try to see in practice how this is used. Now let's see a real life example. As you can see right now, I just reconfigured my home environment, and I added the configuration I showed before. So now we should be able to see the status of the backend, and it is running, and also of the front end. These look like regular Shepherd services. So if I go and do herd status and grep end, we have them as regular services. We can do herd status. We can use herd doc to check the actions, and so as we said before, we only exposed, and as you can see from this herd status call, only the front end is exposed. So both containers are connected to the same OCI network, my network, but only the front end is exposing its port. So we should be able only to run CURL against the backend, the front end, apologies, and not the backend. So if we run to do as before, if we try to do as before to check who's in the backend, we should not be able to do so exactly. But if we do the same for the front end, we should be able to ring the doorbell on the port 7778. Exactly, the front end is up, is exposed, and is able to connect to the backend. And where is the office file then? If we are not exposing our file system, it is in the shared volume we declared, and it is mounted in both containers. And we can try to see the content of the file by exporting the volume and checking the file content. So right now we're exposing my volume, we are exporting my volume. As we can see, we got the office file, we can check the contents of the office, and the office is empty. So the configuration we declared before and that we added to our home environment provisions 3 different kind of services. One network provisioning service, one volume provisioning service, and actually 2 different container-backed shepherd services. Let's see the actions that they support. So starting from the network provisioning service, network provisioning services, we can see it supports only the command line action, which is just a simple action that lists the command line invocation done by the service to create networks. In this case, we have only one network, so we have only one podman network create invocation. The same goes for volumes. Exactly. Only one volume, so only one invocation. In case we have multiple, we would have more than one line here. And the same goes for shepherd services, whose OCI image is just built from Guix packages, as it is the case in our example. So we can go head command line backend, and it gives us our command line. The same for the front end. For containers, which for shepherd services whose container has a remote image, so an image which is pulled on the first run from some Docker registry. We have an additional action available in herd. So if we look, for example, at the Forgejo shepherd service, we can see that it supports the command line, so we can run it, and it is pretty similar to what we had before, with the difference that it pulls a remote image, while before we had a local image for the backend and for the front end, and it has an additional pull action. So if we go checking the real-time logs of Forgejo, we can see that by running the pull action, the container, or actually the shepherd, tries to podman pull, in this case, the image that we passed, or if it were Docker, it would do Docker pull. And this image is then cached, and upon service restart, the service will pick up the new image. And this is useful since Docker images are not reproducible and may be changed. Hopefully they are not, but they may be changed in principle after they have been published to the registry. And so in this way we are able to pull the images. So for now, we only described general guile processes that can either live in the host system or in OCI, in OCI containers, but that do not provide any useful functionality for people. The GoCI project is exactly this. So it aims to be the missing link between usable stuff and the Guix system. What I mean by this is that services in Gocix are supposed to be useful to run anything really useful to people using the Guix system. The project is supposed to help people exercise their freedom of being able to do useful stuff with their own hardware, and they are made for the community, by the community, the services in Gocix, and there are all the intentions of collaborating with upstream once underlying packages are into Guix mainline. To achieve this vision, Gocix services strive to Separate as much as possible configurations that pertain to OCI implementation, such as ports, volumes, images, tags, and so on, from application configuration. So, for example, whether the application will use PostgreSQL or SQLite, or whether the application will use, I don't know, HTTP versus HTTPS, or whatever else application level configuration. And you can see this in the Prometheus example I'm showing you. We have an OCI Prometheus configuration and the record and the Prometheus configuration record. The OCI Prometheus configuration, as I said, describes the image where Prometheus will be looked for, the OCI network, and whatever extra configuration the container may need, while the Prometheus configuration is a very simple one-to-one mapping of the configuration file that Prometheus requires. So it describes actual application level configuration. So for example, scrape intervals, timeouts, the number of scraping jobs that Prometheus is supposed to do, and the configuration for them. So this means that once, and if I understand correctly, there is some work going on the Go team branch to make Prometheus bootstrappable from source and able to be included in Guix mainline. So once Prometheus is in Guix mainline as a regular Guix package, we could reuse this if we want. We should be able to reuse this record to upstream it and to share many of the underlying implementations, the business logic, converting this to an actual configuration file can be the same. So a lot of code can be shared between the OCI service and the regular Guix mainline service. Also, whenever possible, services in Gocix strive to have sane, secure, privacy-aware configuration defaults. It is not possible in all cases, but for example, some services allow user to turn off analytics or stuff like that with some simple toggle in the configuration, and the defaults of Gocix are carefully reviewed to, whenever possible, turn off analytics and companies spying on people that use the services. As I said before, the OCI service type deprecates the OCI container service type. It is completely backward compatible, and it brings additional features such as rootless podman support, the ability to provision networks and volumes, and better image caching. So in my opinion, there would be no reason to avoid migration to the OCI service type, but it requires some manual change in our Guix configuration, which is never nice. I'm aware of that, but it should be pretty simple. Here we will look at how we can easily migrate from the OCI container service type to the OCI service type. It should be pretty easy, and there are at least two scenarios, unless I'm missing something. But in case you are a simple a regular user, you should have something like this in your Guix system configuration. So you would be extending the OCI container service type with a simple service, and the extension value would be a list of OCI container configuration records. To migrate this kind of extension to the new service type, first of all, you should have Gocix in your Guix describe output. After that, you should be able to just turn the extended service to the OCI service type and to pass the list you were having before as your extension value inside the OCI extension record, inside the containers field. You should be able to just copy paste whatever you had before in your extension. In case you are a Gix service author of some kind of service, such as the ones that live in OCIX that depend on the old OCI container service type, you probably in the source code of your service type have one call like this one. This comes from the bonfire OCI bonfire service type that lives in OCIX. And so you probably have one service extension extending the OCI container service type, which is bound, which is passed and a lambda, a function, a procedure which takes a single argument, which is the configuration record. In our case, it is the OCI bonfire configuration record, but in your case, it may be whatever other configuration record you pass to your service type. And it should be sufficient, as before, to take the return value of the procedure you were using before and pass it as a value inside the OCI extension record, and especially the containers field of the OCI extension record. So as you can see, the change should not be very much difficult. It should be just a simple change in the way you call the extension. But if you have any doubts and would like to speak more about this, feel free to contact me either on GitHub, email, or we can speak later at the Q&A. So now we'll have a brief look at an implementation of an OCI backed service type. This is the OCI Forgejo service type, which lives in the Gocix channel inside the OCI services Forgejo module. And as you can see, if you have some familiarity with other Gix system or home services, it looks like a regular service, so it extends some extension points, and most notably the OCI service type. So yeah, what this Forgejo service type does is it provisions a Forgejo instance, and for now it only supports out of the box it only supports provisioning of SQLite databases, but in the future this can be extended, for example, to support provisioning of an initialization of Postgres databases as well, for sure. And yeah, let's just skim a little bit through the code. The service supports both Docker and Podman, so yeah, it has some different logic based on whether it is Podman or Docker executing the container. This may be improved for sure, but I was able to make it run in this way. And so yeah, during activation the service just sets up, in case it is needed, a data dir with correct permissions for the account that will be actually running the container. This is especially relevant in case of Docker containers, which are running with the semi-privileged fashion. The service provisions account and group exactly for this purpose, so to be able to run Docker commands in an unprivileged way, and also to limit the directories in the host file system where the container has permission to write, so it can only write to the Forgejo data dir, which is owned by this account group. And as for the container configuration, you can ignore this mainline prefix, which is a technicality that I need to use the record from Guix mainline inside this channel, because there are some name clashes. But yeah, it is irrelevant for the purpose of this video, so we let the container know the image, the path of the log file, a couple of environment variables which are used only with the Docker, since Podman is already rootless. We configure the exposed ports, so the HTTP port for the HTTP web UI, and we map the time zone information, we map the configuration file, and we map the data dir, which can be either a path on the host system, or, as in our case, we will see later, an OCI volume. And that's it. Let's try to see the service in action. Right now, I will describe the implementation of the forgejo.fishinacalculator.me Forgejo instance, which you should be able to visit while you listen to the video, while you look to the talk. And please don't try to hack it before the talk is done. Then you can try to bring it down after the Q&A, but please, for the sake of the talk, for now, leave it alone. So let's SSH into the machine. This is a virtual machine that I'm hosting on a cloud provider, but it could be whatever machine exposed to the internet. So this is just a regular Guix machine. We can do Guix shell, and as you can see, it has some services running, and I will describe them briefly. So we have regular Guix system services. Most notably, we have fail to ban, which is a service used to ban spammers which try to repeatedly fail the SSH login. We have nothing is interesting. We have IP tables, which is both for security of the server. It exposes only SSH port and both HTTP and HTTPS ports. And also it is required for rootless Podman to be able to set up networks and so on and so forth. We have Nginx, which is used as a reverse proxy in this case. So we expose to the internet the Nginx process, which is the regular Guix system service. So it runs on bootstrapped binaries from Guix. We have a Podman Forgejo, which is the OCI service backing the Forgejo instance. We have a SSH daemon, we have my current SSH session, and other regular services. As you can see, we also have SSL enabled in this server, and it is running on rootless Podman. So let's try and see something more practical. So the only prerequisite to be able to replicate this stuff on whatever machine you would like is to have one DNS record pointing to the IP server of the address, and we can check it with NSLOOKUP. So as you can see, right now we already have the DNS record set. Once you have these, everything should be fine, meaning that the chatbot service will be able to ask for certificates and automatically provision them. So we can check the renew certbot certificate service status. It is it is stopped right now because it is one-shot service, but it has already run, as you can see. The certificate has been successfully acquired. We can check that the files actually exist. So here we have the certificate, and yeah, we can have a look at the Forgejo instance. Yeah, exactly. And so this overview is quite nice. It's the new one. It comes from Shepherd 1.0, and as you can see, the Podman Forgejo looks like a regular service. So it has a log file of which the Shepherd is aware. It has actions. It has service requirements, and it is basically as if it were a regular Shepherd service. So let's try and see in detail how we can interact with the container, which is a little bit different than what we did before when we did the example with the home environment. So when using the OCI service type on a Guix system configuration, an OCI container user will be provisioned for you, and that user is the one that runs all the commands, and it is the one that you will need to use to manage, especially to delete in case you need Podman networks or Docker networks and Podman volumes or Docker volumes. And to have access to it, you need root permissions, which should be no problem since you are able to reconfigure your system. So let's try login as the OCI container user. Let's go back to the user home, otherwise Podman commands will need additional work to be functional. And we can now see that we have container running, which is running Forgejo. We can check volumes. Exactly. We can check networks. You should have none right now. Apologies for the mistype. Yeah, we only have the default provisioned Podman one. So yeah, in case you need to delete volumes, to delete networks, you have to use this this user. Otherwise, if you try to do it from your regular user, since Podman is running as unprivileged with the OCI container permissions, you will not be able to look at his volumes or her volumes. So yeah, this is different in case it is in case the OCI backing runtime is Docker, because Docker stores state globally for all users, so every user is able to see, at least in the Guix system default setup, every user is able to see every other Docker enabled user volumes and networks and containers. And Podman is more secure in this regard, and it uses permission separate for each user. So to handle Podman resources, you have to log in as the OCI container user and manage them with that. So to conclude, thank you very much for listening to me. I hope I was clear. In case I was not, please do have questions later in the Q&A. And as you can see, this is the Forgejo instance that I was speaking about. It is not open to registration because I don't plan to keep it up much longer after this talk, but it should be working. You should be able to open pull requests if you want to try to open issues. For sure, you should be able to clone the repository, and basically the instance only contains the script for this talk right now. But yeah, I figured it would be awesome since the Gix community is evaluating the possibility of migrating its Git Forge from Savannah to Codeberg. I thought it would be awesome for Gix user to be able to set up Forgejo instances that should be able, in theory, to federate with Codeberg. So yeah, this is it. I hope you liked it. And thank you very much for listening. Just as a closing remark, I would love to let you know that all this work about the OCI provisioning service is being upstreamed. The issue number is 76081, and any feedback is very welcome, very much. Please try to run the system tests that I attached to the service. And yeah, I sent already a lot of revisions because during the recording of this talk I found out new bugs. Right now it should be in a pretty stable state, but yeah, if you have any doubts or suggestion or feedback or whatever, they are very much welcome. And yeah, thank you very much for listening, and I hope it was interesting. Bye bye.
Thank you, Giacomo. That was very interesting. I did have one. Yeah, if there is any particular service at the top of the wish list for Gocix.
Actually, yes, there are. I mean, personally, at the top of my wish list for the channel, I would say I'm not sure what I will give priority to, but for sure, a WordPress service is very useful in my opinion. As I said at the beginning of the video, I would love for Gix to be able to be used by people or small organizations to self-host useful stuff. And most, at least in my experience, most small organizations slash not so technical people that need to have a landing page or that need to have a website, they are used to WordPress. So I find that very useful. One thing I didn't mention, or at least I didn't explicitate very well, is that for services, is that since the services live in containers, if you want to have a service connect to a database, which in the Gix system, there are already system services to run databases, such as Postgres, for example. You either need Postgres to run as a container connected to the same network as the front-end service, let's say, so WordPress in this case, or you need to expose WordPress to the host network. So to conclude, I would say in my priority, there is WordPress. There is at least one database. I think it will be Postgres, just because I'm used to that, but for no particular reason. And it may also be an OCI service based on the Gix package. So we don't need necessarily to use the untrusted binaries, but we need some kind of way to avoid, or at least I think we need some kind of way to avoid exposing all containers as to the host network. So I would say WordPress, a database, and there is an issue which I had a look at, but did not manage the time to fix, for asking for Nextcloud, which is also very useful.
Yes, Nextcloud was also on my mind. It's what I was thinking of. Yeah, that would be useful. Thanks, Giacomo. So we have another question from Gabriel. Would you like to read it out loud? It's a little bit technical, yeah, about the home module.
Sure. So I'm reading the question now. I see that you have a home module. Do you already have in mind how to implement the home version of the current services? If not, I know that the syncing service has a for home section, which could provide some direction. So I am not aware of how the syncing service is working right now. I don't think it will be. I don't think it will be difficult to move them to home services. So Gabriel, if I understand correctly, you arrived a little bit late, so maybe you lost that. But in the video, there is also an example of OCI services running in Home Shepherd. So I think it is just a matter of adjusting paths. For example, if the container mount some data dir, some directory where they write state, which usually for system services is inside the /var, that will need to be adjusted. It will need to write in the home directory of the user. But I mean, I don't have a clear answer because it depends on the service, but it should be possible. It should not be difficult.
And then we have a comment from Ephraim about what you were saying earlier about Postgres and the previous comment of yours.
Yeah, just to answer briefly. Actually, I'm not an expert in the internals of container and OCI implementation. So I'm sure there is some magic. I'm aware of the containers spawned by Guix. I am not sure if there is a declarative API in Scheme to declare them as system services. But yeah, for sure, it would be a very interesting path, that one, to use the machinery that is already in Guix to create containers from packages to expose the packages that we already have in Guix and for which we have good binaries, I mean bootstrapped binaries, as containers that could be used by, for example, a WordPress service type.
Giacomo, have you been receiving any contribution to Gocix by any other Gixer, or is it mostly you these days?
So I did quite recently, mostly. So I'm not sure if they have another username. So maybe they're here. I don't know. But for example, I got them from Jorge Gomez, which is another. I think they have Guix commit rights. They are an active member of the Guix community. And not many. I mean, for sure, I have not been the best at communicating the existence of the Gocix project. And for sure, it can be proved. There are no tests. Commit messages do not have the very nice standard that usually Guix projects have. And it is because mostly I was doing that for myself and was not sure whether other people were interested. But definitely, if anyone has suggestions, feedback, or would like to help, do let me know, either via email or on GitHub directly.
If not, I think it just remains then to say thank you very much, Giacomo. That was a fantastic video. Fantastic to bring the kind of, to bring Docker and Docker services and the practicality of all of those services to Guix, but the benefit of Guix configuration. So that's really great stuff. And I'm really looking forward to you getting it upstreamed and getting more services. It's great stuff. Thank you very much for the talk. Really appreciate it.
Thank you so much for having me, and also for organizing the awesome guix.social meetings.
All right. Night, everybody. Have a great evening. Bye-bye.
Thank you,
Have a
everyone.
nice evening.
Thanks, Giacomo.
Bye-bye.
See you soon. Bye.